All right, welcome back. We're going to continue with hypothesis testing for the mean this time. When sigma is known, sigma looks like that. That's the population standard deviation. For this section, we're going to simplify the conditions for which we're working. Though these conditions are unrealistic, it will provide an environment in which we can familiarize ourselves with the process. So we have a simple random sample from the population of interest. There is no non-response or other practical difficulty here. The variable we measure has an exact normal distribution in the population here. We don't know the population mean, but we do know the population standard deviation sigma. The steps taken in performing a hypothesis test are the same as we did before. Establish the null and alternative, determine the critical values for the given level of significance, and draw a graph and label with the critical values. Gather data and determine the value of the test statistic, and draw a conclusion based on the value of that test statistic, or use the p-value method. Computer Program Designer has developed an online questionnaire she believes will take an average time of 15 minutes to complete. Suppose she samples 35 volunteers and finds that the mean time to take the test is 14 minutes with a standard deviation of 2.5 minutes. Determine if there is sufficient evidence to conclude that the completion of time of the online questionnaire differs from its intended duration. Differs is the key word here. 0.05 level of significance. So the alternative claim here is that the mean is other than 15. The null hypothesis here is that the mean is 15. So in the sample, we found that x bar was 14 minutes. Standard deviation of 2.5. So determining the null and alternative hypotheses here, we get that, and then determining the critical value for alpha is equal to 0.05. It's a two-tailed test here. So the critical values here are negative and positive 1.96, which are labeled right here. And therefore, since it's a two-tailed test, if the test statistic falls within either of those regions, then we would reject the null hypothesis, which means that we have a successful alternative claim. Determine the value of the test statistic. Looks like it's going to be negative 2.37 because it was already sitting there. Yeah. Negative 2.37 using that formula. So we reject the null hypothesis, and there is sufficient evidence to conclude that the average time differs from 15 minutes. Yay! The p-value method is as such. Remember that the main difference between the p-value method here is that we compare the p-value with the alpha level. If it's less than or equal to, then we reject the null hypothesis. If it's greater than the value of alpha, then we fail to reject FTR, the null hypothesis. So Wikipedia reports that in 2006, the average American woman is 25 years of age at her first marriage. A researcher claims that for women in California, this estimate is too low. So the claim here would be that the average age is less than 25. The null would be that it's not less than 25, or at least 25 years of age. Surveying 213 newlywed women in California gave a mean age of 25.4 years with a population standard deviation of 2.3 years. Using a 95% confidence level, meaning alpha is 0.05, determine if the data support the researcher's claim. So using the calculator to perform a test here, we would do a z-test, given that we know the population standard deviation. We're going to enter statistics here because that's what was given to us. The mu0 here would be the claimed mean, which is 25. The sigma is given to be 2.3. X bar is 25.4. That's the sample. N is 213 values. And would it be a left, right, or two-tailed test? Based on this symbol less than, we use less than, which is a left-tailed test. So we have a p-value of 0.994 approximately. Which is much greater than alpha. So we would fail to reject the null hypothesis. Therefore, the data do not support the researcher's claim. So once again, the p-value is calculated by, let's see, it looks like we are doing a right-tailed test here. Oh, excuse me. It looks like the alternative hypothesis said that we are going to the right of 25. The researcher claims, oh, too low, right. The researcher claims that it's too low, means the researcher claimed it was greater than 25. My mistake. So when I did the calculation, I should have chosen the test to be a right-tailed test. Everything else was correct. So a right-tailed test, you can see that that will skew the results. And there we are, 5.57%. So now that gels with what the slide said here. So my apologies. Anyway, so we do reject the null hypothesis in this case, because it's smaller here than this is smaller than the significance level, 0.05. Remember that 0.0055 is 55 ten-thousandths, and this is 0.0500. This is 500 ten-thousandths, and this is 55 ten-thousandths. So we would reject the null hypothesis, and we say that we support the claim here. A recent study showed the average family in Europe has 1.48 children. Excuse me. A global watch group claims that German women have an average fertility rate which is different from the rest of Europe. Different would be not equal to. To test their claim, they are surveying 128 German women. So the alternative claim is that the mean number of children is not 1.48. That's the alternative claim. The HO, or the null, would be that it is equal to 1.48 children. N is 128. Standard deviation is given to be 0.84 children. And we're at the 90% degree of confidence here, so alpha is 0.10. Let's double check that we got that correct so far. Yes, okay. So we are going to test the claim similarly to the last example with a z-test using statistics of 1.48 for mu. Sigma is 0.84. The x bar is 1.39. 1.39. And n is 128. And here we're going with a two-tailed test because it's a not equal to sign, so calculate there. P is 0.225. P-value is 0.225, which is greater than alpha, so we would fail to reject the null hypothesis. Pretty close, 0.226. We failed to reject the null. There is insufficient evidence to conclude the fertility rate is different than the European average. Now this is an interesting one. If it is true that less than 4 people per day use a particular public restroom at the state park, the park service will close the restroom. And I've had this happen before. I play tennis a lot, and sometimes the public restroom, even during the spring or early summer, is closed because not enough people use it. In order to determine the action the park should take, the number of uses is recorded each day for a 35-day period. Here are the results. Okay, so this is 35 results. So you would want to punch this into your stat edit menu, which I've done already. So if you go stat edit, notice I started with the 3, and then I did 4, 0, 1, 2, and I went all the way down the list, all the way down to 35 values. Okay, so I typed in those 35 values, and then when you go stat and then tests, and then either Z or T test, we can use the data instead. So let's see what they want. At the 5% level of significance, should the park shut the restroom down, assuming that the standard deviation of population is 2.2? So I would say z-test. This time we're going to enter data, okay? And the data is such that the list is from L1, which is what I typed in. The 4 was the number per day that we were looking at. The 2.2 was the standard deviation given. Frequency means, I believe, what's the frequency of each piece of the list. So we're just going to say 1. And then we're looking at a null hypothesis here. Sorry. We're looking at a null hypothesis that the mean is greater than or equal to 4 people per day, and the alternative is that it's less than 4 people per day. So we would use a less than and then calculate. We have a p-value of 3.26%. And for a 5% level, that is less than 5%. So that would support the claim because it would reject the null hypothesis, support the claim of the alternative hypothesis, and yes, they should shut it down. Because of the fact that the monitoring took place in an off-season for the park, they ran the test again and determined that the actual usage was 7 times per day. Did the park make the right decision? All right. So if we use the mu is equal to 7 times per day, then we would change that in the calculator to say that mu would be 7. So if we change that and then we do a calculate menu, then the p-value is almost nothing. However, if we changed the sample data to reflect that it was 7 per day, of course that would be quite different. But I believe that they meant that you would need to have at least 7 per day to determine whether to shut it down, and then that would help you to make your decision there. And that concludes the video.